process work?
So it's a simple but complex.
Okay, okay.
It's from the 10,000-foot view, it's a very simple process. Getting it to work efficiently is the complexity of what we do. So what we do is proprietary. So I'm going to be a little bit vague, but give you the highlights of it. Fundamentally, we take the material, our partner grounds it into a fine powder that has the precious metals in it. We then put that into a chemical leach to separate out the precious metals from the substrate.
Right.
We separate those solids and liquids. The liquid now is a precious metal bearing liquid, which we call a PLS, a pregnant leach solution. So we then take that pregnant leach solution and we run it through what is effectively commonly called Merrill-Crowe precipitation, which allows us to drop the precious metals out of solution into what we call a black powder. So it's a dirty concentrate. That dirty concentrate is a high percentage precious metal material that we ship to a refinery, who then processes it, upgrades it to 99% pure metal, which is then available to sell into the commodities market.
Right. Is the refining process chemical process, or is a melting process, or?
They use a little bit of both. I think, yeah. So it depends on which metal they're going after, I think. But yeah, that's their third party piece there.
Right. So your process comparing to, let's say, the smelting process, I can imagine that the smelting process is very high energy than the process that. So also we can say that this is an eco-friendly process, right? Do you have any idea about what difference you have between, let's say, CO2 emissions or energy approaches against the, let's say, primary one?
So we use 95% less energy, 99% less water than mining, and a smelter for a ton of processing emits 1,500 kilograms of CO2. And so we're next to nothing on what we do on CO2 emissions.
And do you have an idea about what is the percentage of recoveries are you having on this process? Because for give you an idea, if you go for an aluminum, let's say, perspective, obviously it will depend on the technology and the type of material you are processing, but you can be between the low 90s up to 98 melting efficiency. That is really, really good, but you need, as you just said, like sorting processes, very clean and good approach of sorting and segregation. And I can see here is pretty much the same, right? So do you have an idea about the recovery that you are having on this material? Because this material looks like our expensive material.
Yeah, we get over 95% consistently.
Oh, it's
and
good.
Into the 98.
What makes the difference between the 95 and the 98?
Some of it is a little bit on whether or not there's impurities in the piece. Those are the major